we are on direct variation. What I mean by direct variation from the examples is that if you have your x to varies directly as y, it means that whatever happens to your x will affect your y, and there is something working in that. That is, there is a constant in it, and that's why we introduce a constant to eliminate the proportionality sign to have x equals to ky. This is a constant way of a direct variation, and what this simply means is that your k is equals to x over y. The value you will be getting whenever you divide your x with y will be 1. That is, it will be constant. That's why we call it direct variation. From the one we did earlier, when our x equals to 1, our y is equals to 1 over 2. When our x equals to 2, our y equals to 1. And when our x equals to 3, our y is equals to 3 over 2. Let's find the value of x over y in all these three and see what we have. You have your x to be 1 divided by 1 over 2, which is your y. You can simply write this equation as 1 divided by 1 over 2, which is the same thing as saying 1 multiplied by 2 over 1, which equals to 2. In this case, your x is equals to 2. Let's say you have the second one to be 2 over 1, which is our x over y. Don't forget we are using x over y, so your x is 2 and your y is 1. Here you have it to be 2, which is still the same thing as this. When your x equals to 3, you have your y to be equals to 3 over 2. That is, you can write this as saying 3 divided by 3 over 2, which is the same thing as saying 3 multiplied by 2 over 3. 3 here cancel 3 here, and you're left with 2. So that is how a direct variation works. Whenever you divide your x with y, you have a constant value, and that is why it is direct, because they are following the same pattern. An increase in one will also lead to increase in the other, and a decrease in one will also lead to decrease in the other. Now let's move to what we know as inverse variation. From the word inverse variation, when we say something is inverse, it means it is opposite of each other. In this case, in direct variation, an increase in the value of x will lead to increase in the value of y. But in this case, an increase in the value of x will lead to a decrease in the value of y. And when we say x varies inversely as y, it will mean that x is proportional to 1 over y, because we said inverse. It is inverse, it is an opposite of each other. And to eliminate the proportionality sign, what do? We introduce a constant. And introducing the constant now, you have x to be equals to k multiplied by 1 over y, which is the same thing as saying k over y. Now, let's find our k. Our k is equals to xy. Our k is, because if you cross multiply, just like we talked about in subtotal formula, if you cross multiply, you have your k to be equals to xy. Now let's find a simple example to illustrate how x and y can be inversely proportional to each other. We can say x is equals to 2 over y. In this case, our constant is 2. Now let's see what happens. Let's look for the value of y when x is equals to 1. So when x equals to 1, what happens to our y? When x equals to 1, we have it to be 1 equals to 2 over y. If you cross multiply, you have it to be equals to y equals 2. y will be 2 when x is equals to 1, because this is 1 over 1. If you cross multiply, you have 1 multiplied by y, which is y, and 2 multiplied by 1, which is 2. What happened when x equals 2? What happened when x equals 2? When x is equals to 2, your x is 2, you have it to be equals to 2 over y. If you cross multiply, you have 2y to be equals to 2. Then you have your y to be equals to 2 over 2, which equals to 1. Your y is equals to 1. When x is equals to 2, your y is equals to 1. Let's look for when x is equals to 3. Let's look for when x is equals to 3. When x is equals to 3, you have it to be 3 equals to 2 over y, and you have that to be equals to 3y equals to 2, and your y to be equals to what? Yes, 2 over 3. Now let's see the pattern. When x equals 1, y equals 2. Can you see now? Now let's see. X equals to 2, then you have your y to be what? 1. That is, when x increases by 1, y decreases by 1. And when x is equals to what? 3, you have your y to be equals to 2 over 3. And 2 over 3 is actually less than 1. Which means as the value of x is increasing, the value of y is decreasing. This is what we call inverse variation. Let me introduce an example also on inverse variation, and let's see how it goes. This is an example on inverse variation. It says a set of rectangles all have the same area. As x, the length of the side of the rectangle increases, while the length of the other side of the rectangle decreases. They say so y is inversely proportional to x. When x is 2, y is 18. So the first question says write down the formula connecting x and y. Just like we did in direct variation, we have to find the formula that connects x and y together. Let's go on, please. They said your x is 2 centimeter and your y is 18 centimeter. So we have to firstly find the general formula. Since they said our y is inversely proportional to x, you said your y is inversely proportional to x. That is, your y is proportional to 1 over x. Eliminating the proportionality sign, you have your y to be equals to k multiplied by 1 over x, which is equals to k over x. That is, your y equals to k over x. So from this you can make k subject of the formula. So your k is equals to yx. If your k equals to yx, then you come to this that says k is equals to our y is 18 multiplied by our x, which is 2, and that will give us what? 36 centimeter. Yes, that's 36 centimeter squared, which is our k. So as we've gotten the value for k now, we can now go to the formula that says y is equals to k over x, and say our y is equals to 36 over x, and this is the formula connecting the two. The constant we have there is 36, and that constant is our area. Is the area of all the rectangle that they said it is constant. In another question now, they might ask you what is the area of the triangle. Even without supplying all this, the area of the of the rectangle. So the area of the rectangle is 36. Now let's move to the second one that says find y when x is equals to 24. If you are looking for y when x is 24, you go back to the formula that says what? Y equals 36 over x. So you're looking for y when x equals 24, that is y equals to 36 over 24. So 24 goes here 2, and 24 goes here what? Yes, 3. So your y is 3 over 2 what centimeter. In this case, your y is 3/2 centimeter. The second one says find x when y is 12, and we'll go back to the formula again that says y equals 36/x. So you can make x subject of the formula. In this case, to make x subject of the formula, you have x to be equals to 36/y. If you're wondering how I get it, you can go back to the first video we did on subject of the formula and you will see how it is done. So when your x equals to 36/y, you have it to be what? 36. You have your x to be 36/y, which is 12, because this is the second question. And 12 here 1, 12 here what? 3. Yes, your x equals 3. Your x is equals to 3 what? Yeah, 3 centimeter. That is the answer to the second one. And to the third one, looking for our x when y is 6. Still using the same formula for x equals to 36/y. So your x now will be 36/y, which is 6, and your x equals to 6 centimeter. 36 divided by 6 is 6. Thank you for watching this video from the beginning. By the next time, we will be talking about joint variation. Today we've talked about direct variation and also inverse variation. And if you're having any problem after this video, you can try to watch over again, and if you still don't get it, feel free to drop any question you have in the comment section below, and I will answer to the question as soon as possible. Don't forget to like this video and subscribe, so make sure you on your notification bell. As soon as I drop any video, you'll be notified immediately. Thank you very much. Have a wonderful day.